All right, so where we left off in class, we said I cubed can be written as I times I squared, and I squared is negative 1, so that's I times negative 1, which is negative I. And then I to the fourth is I squared times I squared, which are both real numbers, so we can write it as negative 1 times negative 1, which is just positive 1. And then we have I to the fifth, which we can now write in terms of the real number I to the fourth. So we have I times I to the fourth, which is I times 1, which is just I. So as we discussed in class, that's really just starting over at the beginning, because each time I raise the power, I'm just multiplying by I one more time. And so I to the sixth, we can write as I squared times I to the fourth, which is 1 times negative 1, which is negative 1. And so we see this cycle repeating itself, that we had I, then negative 1, then negative I, then 1. And every time we raise a power, we're just going around this cycle. And so if we can get to the real numbers, which is I squared and I to the fourth, then we can reduce these to always have only a power of I to the 1. So this was I to the first, I to the third, this becomes I to the fifth, I to the sixth, I to the seventh, I to the eighth. And so we can say that I to the seventh is equal to negative I. But when we have higher powers, we need to be thinking about how does this cycle affect those exponents. Well, notice if it's an even exponent, it's a real number. Even exponent is a real number. And if it's an odd exponent, then it's an imaginary number. And so looking at I to the 20th, I know it's an even exponent, so it should be a real number. But the question is it positive 1 or negative 1? Notice all of our exponents that give us a result of positive 1 are divisible by 4. And that's really the key to this whole cycle of imaginary numbers, is when I raise I to any power, I can take out the highest multiple of 4, and that just equals 1. So if I can write this as I to the fourth to a certain power, which for 20 I have to raise it to the fifth power, that's I to the 20th, so that's really just 1 to the fifth, which is 1. And that's true for any multiple of 4. So I can write I to the 46th as I to the fourth to the, how many times does 4 go into 46? It goes in 11 times. So there's 44, and I have 2 left over, so I have an I squared. So this is just 1 to the 11th times I squared, which is negative 1. 1 to any power is 1. And so I to the 46 is just negative 1. What about if I have a negative power? Well, a negative power is a fraction. So this is I to the 12th. 12 is divisible by 4, so it's going to be just 1 over 1, which is 1. So again, looking at that, if the exponent is a multiple of 4, then I to that exponent is just 1. If it has a remainder of 1, then it's I. If it has a remainder of 2, it's negative 1. And if it has a remainder of 3, it's negative I. And those are the only possibilities, because if it had a remainder of 4, its remainder would actually be 0. So remainder of 0, 1, 2, 3, 0, 1, 2, 3. And so we can just go around the cycle that way.